Have you ever gazed up at the night sky and wondered, what is the story of these twinkling stars? This simple question sparks a journey of cosmic proportions, an odyssey through space and time. It's a quest to uncover the birth, life, and death of the celestial bodies that adorn our night skies. The tale is as vast as it is mesmerizing, filled with stellar nurseries, colossal explosions, and the silent whispers of dying stars. So, join us as we embark on a cosmic odyssey, exploring the birth, life, and death of stars. The tale of a star begins in the vast dark recesses of space within colossal molecular clouds. These are not just ordinary clouds, but immense cosmic nurseries where the seeds of stars are sown. They stretch across light years, their depths filled with complex molecules, dust, and primarily hydrogen gas, the raw material for star formation. The story unfolds as gravity, the grand puppeteer of the cosmos, pulls on every molecule in these clouds. This gravitational tug compels denser regions within the clouds to collapse under their own weight. It's a slow dance, a delicate ballet that can span over millions of years. As these regions contract, they fragment into smaller pockets of gas and dust, each one a potential cradle for a new star. These pockets are the birthplaces of protostars, embryonic stars still shrouded in their dusty cocoons. As the protostar continues to accumulate mass, its core becomes denser and hotter. The temperature rises, reaching millions of degrees, setting the stage for a cosmic miracle. At these extreme temperatures and pressures, hydrogen atoms in the core start to collide and merge, a process known as nuclear fusion. This is the ignition switch, the spark that lights up the protostar. It's a high-energy dance of atomic nuclei, where hydrogen is converted into helium. In this process, a tremendous amount of energy is released, radiating from the core towards the outer layers of the star. This energy counteracts the inward pull of gravity, creating a stable balance, a state of hydrostatic equilibrium. The protostar thus sheds its cocoon and emerges, resplendent and radiant, ready to join the galactic ensemble. It's now a main sequence star, like our very own sun, shining brightly by burning hydrogen in its core. This is the birth of a star. From a humble gathering of gas and dust in the dark corners of space to a radiant beacon of light and energy, the journey is nothing short of cosmic alchemy. And so a star is born, a new participant in the celestial dance. Once born, stars embark on a journey defined by a delicate balance. The stellar life cycle, much like the journey of life on Earth, is characterized by distinct phases. The most significant of these is the main sequence phase, where stars burn hydrogen in their cores. This nuclear fusion process is essentially the life engine of a star, releasing a tremendous amount of energy in the form of light and heat, illuminating the cosmos with their brilliant glow. In this phase, stars are in a state of hydrostatic equilibrium, a delicate balance between the inward pull of gravity and the outward pressure from nuclear fusion. This tug-of-war between collapse and expansion is what sustains a star during its main sequence phase. It's a cosmic dance, a celestial ballet, if you will, that can last for billions of years. But the dance isn't the same for all stars. The duration of this phase is largely determined by the star's mass. Massive stars, those many times larger than our sun, burn through their fuel at a much more rapid pace. Their nuclear furnaces work overtime, forging hydrogen into helium at a frenetic rate. As a result, these stellar giants live fast and die young, at least on cosmic timescales. On the other hand, smaller stars like our sun lead more leisurely lives. They burn their hydrogen fuel slowly and steadily, maintaining their glow for an extended period. Their main sequence phase can last up to tens of billions of years, far longer than the age of the universe itself. Whether they are massive or small, all stars will eventually exhaust their hydrogen fuel. When this happens, the delicate balance shifts, and the star begins the next stage of its life cycle. But that's a story for another time. For now, let's appreciate the stellar main sequence phase. It's during this time that stars shine the brightest, radiating energy and light across the vast expanse of space, contributing to the beauty of the night sky we admire. The duration of this phase is largely determined by the star's mass, setting the stage for the next act of its cosmic journey. Massive stars, those over 8 times the mass of our sun, have a more dramatic journey. These celestial giants embark on an extraordinary evolution, fueled by the continuous nuclear fusion occurring within their cores. As this fusion persists, it crafts elements heavier than hydrogen and helium, the primary constituents of a star's initial composition. Iron, the heaviest of these elements, begins to form in the core. This might sound like a stellar achievement, but it's here where the plot thickens. Iron, unlike its lighter counterparts, doesn't release energy when fused. Instead, it absorbs energy, creating an unsustainable situation in the star's heart. The core, now laden with iron, can no longer sustain the intense gravitational pressure of the star's outer layers. This imbalance between pressure and gravity sets the stage for a cosmic drama. The iron core collapses under its own weight in a matter of seconds, triggering an implosion that sends shockwaves rippling through the star. This dramatic upheaval marks the end of the star's life as we know it. The energy of this implosion rebounds off the dense core, catapulting the outer layers of the star into space in a cataclysmic explosion. This is no ordinary explosion. It's an event so powerful and brilliant that it can outshine an entire galaxy for a brief moment. Thus, the stage is set for one of the universe's most spectacular shows, the supernova. This stunning finale is the ultimate testament to the star's grand existence, a dazzling display of cosmic transformation that we'll explore in the next scene. A supernova, the explosive death of a star, is a celestial spectacle like no other. Picture the most massive stars, over 8 times the size of our sun, reaching the end of their lifetimes. Their cores, packed with iron, can no longer sustain nuclear fusion, and so they collapse. This collapse triggers a tremendous explosion, outshining entire galaxies for brief moments in time. This is a supernova, a blaze of glory marking the end of a star's life. But supernovae are more than just cosmic firework displays. They play a crucial role in the grand scheme of the cosmos. You see, the elements we find on Earth, the ones that make up our bodies, the air we breathe, and the ground we walk on, are all forged in the heart of stars. And it's the supernova explosion that disperses these elements far and wide, scattering stardust across the universe. In the aftermath of a supernova, the core of the star remains. Depending on the mass of the original star, this core can transform into a neutron star or even collapse into a black hole, further adding to the cosmic drama. So while a supernova signals the end of a star's life, it's also a beginning. It's a celestial forge, creating elements, seeding future stars, planets, and potentially life. These cataclysmic events, while marking the end of a star, serve as cosmic catalysts for the creation of new celestial bodies. However, not all stars meet such a fiery end. Smaller stars have a different fate. Their journey is just as intriguing, albeit less explosive. Let's dive into their captivating story. These celestial bodies, less than about 8 times the mass of our sun, have a more serene existence. As these smaller stars exhaust their nuclear fuel, they undergo a remarkable transformation. They puff up, swelling to hundreds or even thousands of times their original size. This phase of their life is called the red giant stage, a fitting name considering their increased size and change in color. But even in their inflated state, these stars are far from done. They begin to shed their outer layers into the surrounding space, like a celestial butterfly emerging from a cocoon. This expelled material forms what we call a planetary nebula, an enchanting cloud of gas and dust that glows with an ethereal beauty. Now, what remains of the star is a dense, hot core known as a white dwarf. This celestial remnant, about the size of Earth but with the mass of the sun, is incredibly dense. It shines brightly with stored thermal energy, but over billions of years, it will gradually cool and fade. Eventually, the white dwarf will darken and become a black dwarf, a theoretical celestial object that has yet to be observed due to the universe's age. These smaller stars, though less dramatic, also contribute to the cosmic cycle of birth, life, and death. The birth and death of stars is a tale of cosmic proportions. Our journey has been a celestial odyssey, tracing the path of stars from their inception within vast molecular clouds to their dramatic denouements. Born from the collapse of these dense regions, stars ignite into being, lighting up the cosmos with their brilliance. Their life cycles are a delicate dance between gravitational collapse and nuclear fusion, a balance that dictates their longevity. Massive stars, in their fiery hearts, forge heavier elements leading to their explosive end in a supernova, scattering life-enriching elements across the cosmos. Smaller stars, on the other hand, swell into red giants, shedding layers to form planetary nebulae and ultimately fading into black dwarfs. The cosmic ballet of star birth and death is a testament to the intricate beauty of our universe. As we continue to decipher the mysteries of the cosmos, the life cycle of stars serves as a testament to the awe-inspiring intricacies of our universe.